Dear students, welcome to Statistics Online class. In the previous session, we solved some problems on Poisson distributions which will be asked for 1 and 2 mark. Let us solve a few more problems. Next, 8th problem. In a Poisson distribution, if P of x equal to 1 equal to P of x equal to 2, then find its mean. Then find its mean. Now let us solve this. First we have to see what are the given factors. Now here it is given in a Poisson distribution, this information is given. Probability of x is equal to 1 is equal to probability of x is equal to 2. With this given information, we have to find the mean. And we know in a Poisson distribution, mean equal to lambda. So here we have to first find lambda. To find lambda, use the given information. So that is a given P of x equal to 1 is equal to P of x equal to 2. Right? That is what is P of x is equal to 1? That is the second probability term of a Poisson distribution. Similarly, this is a third probability term of a Poisson distribution, and it is given in a particular situation those two are equal. When those two are equal, what is the value of lambda? That we have to find. Now for that, first substitute x is equal to 1 in the probability mass function. E power minus lambda, lambda power x is 1 divided by 1 factorial. That is I have substituted x is equal to 1 in the probability mass function. E power minus lambda, lambda power x divided by x factorial. In place of x, just I wrote 1. Similarly, in the right side also, substitute x is equal to 2 in the probability mass function. That is e power minus lambda, lambda power 2 divided by 2 factorial. Right? Just a substitution. Next, try to simplify this. E power minus lambda get cancelled. Next, remaining factors, lambda power 1, that is lambda divided by 1 factorial 1, which is equal to lambda square divided by 2 factorial. 2 factorial is 2 into 1. Now with the help of this, we have to find lambda. Now just cross multiply. This is a 2 into 1, bring 2 to the left side, 2 divided by, this is a cross multiplication, divided by 1 is equal to lambda square divided by, bring this lambda to right side, so it becomes a lambda. Just a cross multiplication, and keep the unknown factors one side and known factors another side. Now simplify, you will be getting lambda equal to 2. Therefore, lambda equal to 2. Now lambda square, lambda 1, here 1 lambda get cancels, right? So lambda cancels, then the lambda remains. Lambda equal to 2. So once you know lambda equal to 2, then it is asked to find the mean. Therefore, mean equal to lambda, which is equal to 2. Now it is one of the important 2 mark question. One more problem. A 9th problem, I am going to continue here. That is in a Poisson distribution. In a Poisson distribution, P of x equal to 2 equal to P of x equal to 3. Find P of x equal to 4. Find P of x is equal to 4. Now once again here, what is given, what is asked, that we have to see first in the question. In a Poisson distribution, it is given some information, that is 2 probability terms are equal, it is given. Find one more probability term. And we have studied earlier to find the probability of x is equal to any value, first we must know the parameter. And here the parameter is a lambda, which is not known, but we know now we can find lambda with the help of the given information, right? So with the help of the given information, first find lambda, and after finding lambda, substitute in the probability mass function lambda equal to something, as well as substituting the value of x in the probability mass function, we can get p of x is equal to 4. So first use the given information to find the value of the parameter. So given p of x equal to 2 equal to p of x equal to 3. Now after that, p of x is equal to 2, that is e power minus lambda, lambda power 2 divided by 2 factorial. E power minus lambda, lambda power 2 divided by 2 factorial is equal to e power minus lambda, lambda power 3, x is 3 divided by 3 factorial. Now just to simplify, e power minus lambda get cancelled. Next remaining factors cross multiply. Bring this 3 factorial here and lambda square here, so that we can have lambda in one side and the known values in another side. So here 3 factorial bring to this side, that is 3 into 2 into 1 divided by 2 factorial. This is the 2 into 1. Which is equal to lambda cube, right, as it is. Next, cross multiply, that is bring lambda square here, right? Cross multiplication, simplification, this is purely mathematical. Now 2 into 1 get cancelled, 3 remaining, lambda square, and here 1 lambda remains. Instead of 3 you will be getting 1, right? So lambda, you will be getting lambda equal to 3. So here the answer is lambda equal to 3. Next, it is asked to find the probability of x equal to 4. So first write probability mass function. Therefore, probability mass function is PMF is P of x equal to e power minus lambda, lambda power e power minus lambda means here what is the value of lambda? Here lambda equal to 3. Just now we obtained. We can substitute it, e power minus 3 power x divided by x factorial, right? X is equal to 0, 1, 2 up to infinity. It is the probability mass function. Now put x is equal to 4 in the probability mass function, that is p of, therefore p of x equal to 4 is equal to e power minus 3 power 4 divided by 4 factorial. E power minus 3 power 4 divided by 4 factorial, which is equal to e power minus 3. In the last class, I told how to get the values of e power minus lambda from the table. So here we must find e power minus 3 from the Poisson table. And the value is 0.0498. You will be getting it from a table into 3 power 4. 3 power 4 is 81 divided by 4 factorial. 4 factorial is 4 into 3 into 2 into 1. Now simplify this, you will be getting 0.1681. This is how to find the probability of x equal to 4 when some condition will be given on probability terms. It is also a 2-mark question. Next, one more question. In a Poisson distribution, second probability term is half of the first probability term. second probability term is half of the first probability term. Question is, find the standard deviation. Find the standard deviation. Now once again, some informations are given in the statement, right? Which information? The second probability term is half of the first probability term. Now what is second probability term? Second probability term. Now here, in a probability distribution, the first probability term is P of x equal to 0 in a Poisson distribution, right? So here, P of x equal to 0 is the first probability term. But in the problem, it is given second probability term. So in a Poisson distribution, the second probability term. So what is second probability term? Second probability term. What is it? That is a P of x equal to 1 is called as the second probability term. Similarly, what is first probability term? First probability term is equal to P of first, means we must write x equal to 0. Now here some relationship is mentioned in the problem, that is a second probability term is half of the first probability term. So given the second probability term, that is a P of x equal to 1 is equal to half of the first probability term. Half of first probability term. This is what is given, right? So statement is given, convert it in a mathematical form. Now once you know this, next procedure we know, just now we solved two problems. In the similar manner we can solve. Here first put x is equal to 1 in the probability mass function, that is e power minus lambda, lambda power x, x is 1 divided by 1 factorial is equal to half into P of x is equal to 0. So e power minus lambda, lambda power 0 divided by 0 factorial. Now just substituted the values of x in the probability mass function. What is asked? Find standard deviation. Standard deviation we know in a Poisson distribution, standard deviation is a root lambda. Is it right? So we have to find the root lambda, that is the lambda should be known. First find the lambda. To find the lambda, we followed this procedure. So now simplify this, the answers. Here e power minus lambda get cancelled. What remains? In the left side, lambda power 1, that is here you can get lambda power 1 is lambda, and divided by 1 factorial, 1 is equal to half into lambda power 0, 1 divided by 0 factorial 1. What do you get? Lambda equal to half or 0.5. So here lambda equal to 0.5. Next, therefore standard deviation is equal to root lambda is equal to root square root of 0.5. Square root of 0.5. The answer is 0.7071. So now we solved 3 problems. All are very, very important questions. Next question is 11th problem. First two frequency terms. First two frequency terms. First two frequency terms of a Poisson distribution are 150 and 180. 150 and 180 respectively. Find the next frequency term. Find the next frequency term. Find the next frequency term. Now here we are not dealing with the probability terms, instead dealing with the frequency terms. So frequencies means theoretical frequencies. Those are represented by Tx. And here, what are the given factors? First two frequency terms are given. First two frequency terms are denoted by T0 and T1. First frequency is T0. Next, second one is T1. So here, given in a Poisson distribution, the first two frequency terms are, that is a first frequency term. First frequency term is equal to T0 is equal to 150. First frequency term is 150. Next, similarly, second one. First two means first and second. Second frequency term is equal to T1 is equal to 180. And it is asked, find the next frequency term. Next frequency term means a third frequency term. So, what is a T2? We have to find the value of T2. Now, here to find T2, that is with the help of the recurrence relation, where we can find the successive frequency terms as in a binomial distribution. Now here T0 and T1 are given. With the help of that we can find T2. But to find T2, we have seen the recurrence relation is Tx is equal to lambda by x into Tx minus 1. To use recurrence relation, we must know first the value of lambda. So first, with the help of the given information, we must find the value of lambda. So for that, we can use these two terms. These two terms means T0 and T1. Now just see this recurrence relation. Can we use this to find the lambda? Now Tx and Tx minus 1. In those two places, we can write T1 and T0. Put x is equal to 1. You will be getting T1 minus 1, T0. So here it becomes a T1, then this factor becomes a T0. That is, if we are going to substitute x is equal to 1, then we can write T1 equal to lambda divided by x. X we have substituted as a 1. Now this is known, T0 is known, lambda is unknown. Now we can find lambda, right? So this is the method how we can find a lambda. With the help of the given information, so we can find a lambda. By which relation? By recurrence relation. So by recurrence relation, Tx is equal to lambda by x into Tx minus 1. Now put x is equal to 1. You will be getting T1 is equal to lambda by 1 into T1 minus 1. 1 minus 1 is a 0. Now what is T1? T1 is 180 is equal to lambda divided by 1, that is lambda itself, into T0. T0 is a 150. Right? This implies lambda is equal to 180 divided by 150, or we can write lambda equal to here this is a 1.2. So we can observe here lambda equal to 1.2, the parameter, right? Next, once you know lambda, once again use the same recurrence relationship. Once again use the same recurrence relationship to find the next frequency term. Next frequency term is a T2, third frequency term. Now once again use recurrence relation. Tx is equal to lambda by x into tx minus 1. Now which x we have to consider? T1 over T0. I have to find T2. So suppose if you are going to put x is equal to 2, what happens? Put x is equal to 2, then T2 is equal to lambda. Lambda we just now we calculated, it is 1.2 divided by x. X is a 2 into T 2 minus 1. 2 minus 1 is a 1. Right? Do you follow this? Next, 1.2 divided by 2 into T1, that is a 0.6 into T1. T1 is a, it is given, that is a 180. Right? So 0.6 into 180, the answer is a 108. So first frequency term, second frequency term, it is a next frequency term, that is a T2. Third frequency term, it is a 108. Next one more question. In a Poisson distribution, first probability term is 0.2725. Find the next probability term. Find the next probability term. Now what is given here? What is given? Now here first probability term is given, that is in a Poisson distribution, first probability term is a P of x equal to 0, which is equal to 0.2725. It is asked to find the next probability term. Next probability term is nothing but a second probability term. Second probability term is P of x is equal to 1. P of x is equal to 1. Now first, with the help of the given information, we have to find first what is the value of lambda. Can we find this? Yes, that is right first. That is in the probability mass function e power minus lambda power 0 divided by 0 factorial, which is equal to 0.2725. Now here e power minus lambda power 0 is 1 divided by 0 factorial 1, which is equal to 0.2725. Right? Now from the table, that is in the Poisson table, look at the body of the table. There identify where 0.2725 exists. Move in the same row, same column, you can find the value of lambda, and you will be getting lambda equal to 1.3. That is from the table. That is a 0.275. Identify in the same row, in the same column, you can observe 1.3 is there. This is how to obtain the value. Next, after that, we have to find the next probability term. That is to write the next probability term in the probability mass function, put x is equal to what? 1. So the next probability term is P of x equal to 1, which is equal to e power minus lambda, that is 1.3 into lambda power x, that is lambda is 1.3 power x, x equal to 1 divided by 1 factorial. Right? Now, which is equal to 0.2725. E power minus 1.3 is already we know that e power minus 1.3, or just look at the table, that is minus 1.3, you will be getting the same value. into 1.3 power 1.3 divided by 1 factorial, that is a 1 itself. So the answer is 0.3543. 0.3543, right? Next is a small problem I am going to solve now. That is a problem number 13. Given that 3 into P of 2 is equal to P of 4. Find variance. Find variance in a Poisson distribution. Now what is given? 3 of. So to find variance, we must find lambda, because variance is equal to lambda. What is given information? Given 3 into P of 2 equal to P of 4. P of 2 is P of x is equal to 2. P of 4 is P of x is equal to 4. Now, substitute the values of x in the probability mass function. 3 into e power minus lambda power 2 divided by 2 factorial is equal to P of 4 e power minus lambda power x is 4 divided by 4 factorial. Now 3 into e power minus lambda get cancelled, that is a lambda square divided by 2 factorial, 2 into 1 is equal to lambda power 4 divided by 4 factorial, right? This is what you are getting. Now continue this. We can simplify some factors. Bring this product to left side, bring this lambda square to right side. So you will be getting 3 into these factors. 4 into 3 into 2 into 1 divided by 2 into 1 is equal to lambda power 4 divided by lambda square, right? Here 2 into 1 get cancelled. This is a 36 and lambda square, lambda power 4, you will be getting lambda square, which implies lambda equal to square root of 36, that is 6. So the parameter lambda equal to 6. Therefore, variance is equal to lambda equal to 6. This is how to find the value of variance. Okay, thank you students.